Alright, so here's the test setup. I've got one of the additional input-output harnesses. Okay, so this is a red 5-volt input. Let's see, this white that I've gotten stripped back is the sensor ground. And then the orange is a 5-volt sensor reference wire. So pretty much all these sensors you're going to need, it's going to be a reference across 5 volts. So you have 3 wires like this map sensor here, this MSD map sensor, 3 wires. It's got a 5-volt positive, ground, and a sensor. So all I'm going to do is very simply, I'm going to look up the wiring diagram for this sensor, which I've got the connector for. And the connector is noted with 3 initials. A C, I don't know, let's see if we can see that. It's got a CBA. Basically, red's hot, blue's ground, white's your signal. So you match it up to how it plugs in. Boom. You know which one's which. The actual MSD sensor doesn't really say. Anyway, so what I'm going to do is I'm just going to shove these wires down in this sensor, tape them on there, and then I'll put, this is the vacuum hose that I was using. We'll be putting this vacuum hose with the gauge on the sensor, and that'll be it. What I was doing to simulate the internal map, this is the port for the internal map on the Sniper. It's actually threaded. It's a super small thread. It must be, I don't know, some kind of machine screw or something. I don't know if you can see that it's threaded down in there, but anyway, I'm just holding this vacuum line up to this, and I really don't care that I get an accurate reading. All I care is that I can prove whether or not this thing will read more than 16 pounds, which we showed that it'll read about 22 pounds or 250 kPa. Now I'm going to put this MSD sensor, you saw the part number on there, it's a 3-bar map sensor. Show you how to see if it works. Well, there it is. Perfection. And then we'll just plug this into the appropriate idiot-proof connector. See if we can one-hand this job. And then I will swap back over and show you how to click. Swap back over to the computer and I'll show you how to set up a custom input for that map sensor. So here we are back at the home screen. All I did was just, this is what you would see if you plugged in your Sniper to your laptop and hit open from ECU. So what we'll do next, we're going to verify that this is, the original program. You can't see up here above, but this is the 4150 SS default wizard generated VE table, fuel flow table, whatever you'd like to call it. It's got a really pretty graph for the most part. There you go. Looks like some jackled's done gone and messed with it. I guess it was me. So now what we're going to do is go onto our sensors and configure a custom map. Because map sensors are generated in kPa, first thing we're going to do is take this preference off to have the map represented as PSIG. I'm going to enable a custom sensor. I'm going to call it 3-bar map. And then we're going to pick the Holley 3-bar because I'm sure the scaling is the same since this is an MSD sensor. The input that I have is number 4. We've got 315 kPa on the screen. Perfect. Now, let's go to our map section. We're going to tell this, guess what, map, we have 315 kPa now. And then we're going to let this fill the row, rescale its whole map setup deal. Now we can go to this here, and so I'm going to put 315 here, and then we'll fill this row. You have to do those things in that order. You have to tell the map that it is now 315 kPa, and then you can change this axis. I had a lot of trouble with that at first. Then we'll go back and look in here. Actually, let's see if we can undo that. So we'll undo that and check the fuel flow. We know that we can change it. We just want to look at the fuel flow rates. So we'll pick 4,000 RPM at 240 kPa, 425 pounds per hour. We'll change the scale here to 315, rescale it, and we'll look for that cell again. I'm going to refresh it by going just back and forth. Now we'll look for 240 kPa, which is going to be about right here. And you can see it's now 338 pounds per hour of fuel. So it redoes the whole fuel flow scaling, but you do gain some resolution now, and you can go back in here and change this to PSIG because no one talks in kPa except for programmers. And there you go. Now you see this much of your scale here out to 8,000 is vacuum conditioned to wide open throttle with no boost, and all of this resolution is now with boost. So you get a lot more, a lot better resolution when you auto scale it. I guess you could go through here and manually scale things if you wanted to. I just don't have time for that for this video. I'm just trying to make this short and sweet. I'm going to be looking into other things. So this is just showing the map sensor. But eventually I would like to see if how the Sniper runs boost control solenoids, which I've got a couple of Mac valves from Motion Raceworks. We want to link this, so first I'm going to do is send this configuration to the ECU. Okay, and now you can see our little circle down there in the bottom. We'll test it. So we'll test it in between different areas to try to show that this map sensor does have some granulation. It's not just off and on. Oh, epic fail. I forgot to do something, guys. I totally forgot. So that's what you'll see. I'm showing 20 pounds on my gauge. I'll disconnect this. That's what you'll see when you don't tell the computer to use the external map sensor. So I'll go into E5 parameters. Tell it use your 3-bar map sensor now, please and thank you. Go back over here to our fuel table. Go live. Send that information to you. And see where we're reading. Okay. If this jumps around a bit, it is likely due to my tape job, but I'll try to go slow with the gauge. There you go. There's you a little bit. It looks about 10 pounds on my gauge. It's showing, looks like 180 kPa down here. You can see in the bottom left. And then we'll give it just a little bit more. That looks like about 20 pounds. Yep, 250 almost kPa. and then we'll keep on creeping up. I've got just a little under 30 pounds in this machine, so you can see it goes all the way up to 28, 290 kPa. You want to verify it on your little gauge set. There it is. What else do you want to know? I mean, so there's using the sniper, showing that it will read boost. You will have to redo your fuel tables. It's seasoned now because my tape's coming loose. It's just holding these wires in. I'll fix those in a more permanent situation once I go to install this. Eventually I will be testing MAC valves. I will be testing them as a dome boost control deal. Maybe testing nitrous, but more interested in testing the MAC valves, getting them working right, and then I'll also be acquiring an ethanol content sensor and a digital to analog converter to do some testing with ethanol fuel trims as a 0 to 5 volt input on the custom sensors with the sniper. So we'll see how this goes. I know a lot of people are running ethanol with the sniper. They're just, increasing their cubic inches. You just go into your system configuration, increase the cubic inches by 30%, not to 1,000. It's about 430 cubic inches or whatever. But anyway, you can increase your cubic inches by 30% over what your actual cubic inches are, and it'll modify your whole base fuel flow table. That's one way of doing it, but you're going to run out of injector. I'd like to see if there's some other injectors I can get in here. Anyway, thanks for watching. If you have any comments, feel free to leave them.